This is the most fun that I've ever had with a 3D printed airplane. Wait till you guys try out this optional fin and rudder. It makes flying this airplane a lot of fun. This F-22 is a highly capable park flying pusher. You can easily lock into high alpha. And it's even capable of high alpha turns using the optional vectored rudder. This 3D printed Raptor is a high performance park jet that can be kept in a tight area. Capable of high speed and vertical flight, she'll really rip when you open her up. In this video, I'm going to provide you with detailed instructions on how to build one of these for yourself. I'm going to assemble the entire model from start to finish and even go over electronic and motor installation. I left a link in the description to where you can find the model files. The model does come with 3 MFs and G codes to help get you out to the field faster. The one we're going to assemble today was printed using the G codes that come with the model files. And we're going to build it with the recommended motor, prop, and servo setup. I'm also going to provide build tips that would help with other models as well. By the end of the video, you'll have all the knowledge and tools you need to have a successful first flight. If built using the recommended print settings and recommended motor and prop are better, this F-22 has all the power you're ever going to need. This airframe's a lot of fun to fly whether you're new to the hobby or an experienced pilot. The Elevons and vectored rudder give you a tremendous amount of control, and its unique flight characteristics will make you fall in love with it. It's highly agile and can get out of bad situations very easily. This airframe will help you sharpen your skills no matter where your ability level is. The orange 22 seen here was printed with 4% infill in the wings and the fuselage. The yellow 22 is printed with 1.5% infill in the wings and fuselage, and built with all the recommendations provided with the model files. The two fly completely different. The control surfaces and tailpieces all print with vase type structure to keep the ass end of the airframe as light as possible. I highly recommend following the print and build recommendations as best as possible. This way you know your Raptor will be high performance and highly agile. Using a smaller motor and prop or higher percent infill will make this airframe fly closer to a jet where you need to keep your airspeed up. Haul in the mail. Let me know in the comments what you guys would like to see me build next. Alright, I've had about enough BSing for now. Thanks for watching guys and welcome to my channel. My name is Bill from HoloModels RC. This is my F-22 Parkflier pusher, and let's get down to business. I'm going to start by prepping all the fuselage parts. I'm going to use this steel wire to make sure I have no clogs in any of the holes where the carbon fiber or steel wire will be inserted. I'm also going to do this in the holes for the vertical fins and where my pushrod wire is going to go. Now I'm going to strip the vinyl off the steel yard flags. The flags can be substituted by 1.5mm carbon fiber. In this build I'm going to use both, but it's completely up to you how you want to build yours. I left a link to everything I used in this build on the main download page of the model. I'm going to assemble the fuselage working from front to back. First I'm going to insert the steel wire into fuse 1. Next I'm going to route the other end of the wire into fuse 2 and feed it all the way through. Be sure to leave room for CA. Go ahead and glue fuse 1 and 2 together. Try to do the best you can to align these parts. I always use a napkin to clean up excess glue. Hit that with accelerator. Make sure I put some pressure on it. Now I'm going to move on to fuse 3, feeding the wire just as before. This wire will help support the battery and keep the nose from breaking off, especially when you stand it up in the car. Now I'm going to insert 2 more yard flags into fuse number 3. These steel wires do a great job to help strengthen the model and limit the amount of PLA used. I'm going to feed them into fuse number 2. Using steel wires on the bottom of the airframe will help a lot with belly landings, and they're significantly cheaper as well. Now I'm going to glue fuse 2 to fuse number 3. The yard flags or carbon fiber do not need to be glued in. Now slide fuse 3 forward into fuse number 2. Wipe off the excess glue and hit it with accelerator. I would rather use extra glue and have to wipe it off than to have to add it to the outside of the model. Now I'm ready to feed the steel wire into fuse number 4. Slide fuse 4 forward, and we're going to check and cut the length of the center wire. I'm just going to pinch it with my thumb and eyeball it. I always go a little bit short. I'll cut it about here. Go ahead and cut this wire about a 1/4 inch short like I did here. Always dry fit your parts and make sure they're going to fit before applying glue. Now I'm going to apply glue to the back of fuse number 3, again to the forwardmost part. Slide fuse 3 and 4 together. Make sure that center wire goes in its hole. Make sure the outside of the fuselage is flush for the wing. Wipe off your excess glue. Hit it with accelerator. Moving on to fuse number 5. Just as before, route the steel wire into fuse number 5. In this build I'm going to use steel on the bottom and carbon fiber on the top, but you can do it however you want. The steel yard flags are much cheaper. Always keep the yard flags or carbon fiber forward as much as you can. You would think them aft booms are more important, but I found it's much more important to strengthen the battery area. If you use 4 steel yard flags for this, it doesn't matter. They'll go all the way from front to back. Plus, carbon fiber that long is much more expensive. It's easier to leave the wires in while you're gluing, instead of feeding them after you have glue on there. Make sure you leave room to get your hand in there to glue it. One last check to make sure the wires are all the way forward. And again, we're going to apply glue to the frontmost part. This way there's no chance of the glue getting stuck to the carbon fiber and not being able to slide the part forward. Now slide fuse number 5 into fuse number 4. Quickly clean up my mess. Make sure to get the left and right sides of the fuse as flush as you can. This way there will be no gap in our wing. Hit that with accelerator and keep forward pressure on it. It's looking pretty good, let's keep moving forward. Grab both fuse 6 pieces so we can cut these wires to length. The cut line on the bottom of this part will indicate how deep the wire is going to go. I'm going to cut it about a 1/4 inch short. Now if you use steel wires on the top, they will go all the way to the back end of the aircraft. Let's go ahead and cut the other side as well so it's a little easier to work with. It's now time to assemble fuse number 6. I'm going to use a steel wire to help align these parts as I glue them together. I'm going to start with the 2 innermost stab pieces. Glue the 2 inner stabs together. Try to get them as flush as you can. Make sure you don't glue the steel wire in. Might be a good idea to hit it with accelerator. Now I'm going to insert this steel wire through all 3 parts. Fuse 6 L and R and the stab pieces. This is not required. You can just glue them together if you want. Like I said, we're just using this steel wire to help align them together. Apply glue to the stab pieces themselves, not to the booms. If you look at these aft booms, there's a recession where the stab goes, and you can feel it kind of lock into place. The depression in fuse number 6 helps to align the stab and makes it very easy to get it straight. As you're holding it together, twist it around a little bit to make sure it's seated correctly. Be sure to keep pressure on it as the glue dries. Check the back end where the elevator goes to make sure the hinge line is nice and straight. Now we're going to do the other side. Be careful not to glue this steel wire in. Same thing as before. Apply glue to the stab and thread fuse number 6 right onto our guide wire. The depression in fuse 6 will make aligning the stab very easy. Seat the stab directly into the impression and keep gentle inward pressure on it. As you're holding it together, give it a gentle twist to ensure it's seated correctly. And again, check the aft end to make sure the hinge line is nice and straight. Be sure to keep moving your steel wire so you don't glue it in. We don't need that in there anymore. I'm going to hit the hinge line with accelerator. Now that fuse number 6 is together, I'm going to feed these steel wires into it. It's always good practice to check the fit before applying glue. It's much easier to leave all the wires or carbon fiber inserted inside the parts while you're gluing it. Be careful when gluing these parts together. You don't want to accidentally glue the wire and then not be able to move these pieces forward. If you think you're going to mess this up, apply glue to fuse 5, not fuse number 6. Do your best to keep the outside flush where our wing is going to sit. Be sure to keep forward pressure on it while you're wiping off excess glue and adjusting its fit. Make sure the left and right sides of the fuse are flush for the wings. I'm going to do this for both sides. I'll hold it flush with my fingers. I'll use accelerator right in that critical area first. Now I'll do the other side. Check again to make sure the outside's flush. Maintain forward pressure while the glue dries. Now I'm going to go around the entire thing with accelerator. Let's set the fuse aside and start construction on our hatch. These are the 2 pieces of steel wire I cut from the fuse. You could use them in the vertical fins, but I'm going to use them here. Now we need to cut this steel wire to length. Align both hatch pieces together. Make sure to cut it about a 1/4 inch short of the line that you see on the bottom of the hatch. Be sure to check the fit before applying glue. Go ahead and glue it all together. These wires are not required, but it does help align the parts. Align these parts the best that you can. Wipe the glue off the outside of the hatch. Get it as flush as you can. And then we're going to hit the inside with accelerator. Grab the lock parts that are printed solid and a small rubber band. There may be a little bit of stringing on hatch front where the slide lock sits. You can clean that up with your spatula. Insert the slide lock like this with the pin forward. Apply just a little bit of glue in these corners. Put the lock holder in and slide it as far aft as you can. It's a good idea to keep moving the slide lock so you don't accidentally glue it in. Now I'm going to make sure I have enough glue on the lock holder. Be sure to keep moving it until the glue is completely dry. It's a good idea to get an accelerator up inside there. Go ahead and put the rubber band on. Now we're going to put the aft pin in the hatch. You can use a generous amount of glue here. It doesn't matter which way you insert this pin, it's perfectly square. Push it into its slot and slide it as far forward as you can. I'm going to go over it one more time with CA, then hit it with accelerator. Once the hatch is completely dry, let's see how it fits. Turned out very nice. Moving on to the Elevons. I'm going to start with the left side. Go ahead and apply glue to one side of the Elevon. We can use the table to help us align these parts. I always start with the control horn first and then align the rest of it. I'm going to clean that up a little bit. Make sure to keep pressure on the control horn itself. Hit that with accelerator and check the rest of it. Moving right along to the right side. Now let's do the exact same thing to the other Elevon. We can use the table as our friend here. Before the glue hardens all the way, I'm going to clean the control horn out with my music wire. It'll be a little bit easier this way. I'm going to do this to both the left and right sides. Now that the Elevons are finished, let's put them aside for now and get started on our wing. It's important to note that the wing can be printed and built several different ways. If you have a small bed size, you can print the wing in pieces. And if you have a large bed size, you can print the wing whole or half. The main difference is the tolerance in wing number 4. Each side will require wings number 1, 2, 3, and 4. You can print numbers 1, 2, and 3 together, and you can also print numbers 1 and 2 together. Wing number 4 has a different tolerance depending on which parts you use. There's STLs, 3MFs, and G codes for all of them. I'm going to go over both ways, but I prefer to print my wing whole. Just like with the fuselage, let's take this metal wire and clean all the holes out in our wing parts. Sometimes it helps to stand the part up while you're doing this. 2 wires and or carbon fiber can go here. Now I'm going to insert the steel wire in the forward hole. It's going to go all the way across both wings. On this build, I'm going to use steel wire in the front and carbon fiber in the rear. This way, at least I have one continuous piece that goes all the way across both wings. Now I'm going to feed both the steel wire and carbon fiber into my wing. I'm going to slide the wing onto the fuselage. Next, I'm going to cut the carbon fiber to length. Now I'm going to apply a generous amount of glue to the wing. I'm going to slide the wing back onto the steel yard flag and push that steel yard flag all the way through the wing. I don't want to accidentally glue this in just yet. It helps to stand the fuselage up on the side while you're doing this. This way we will not have sag in our wing when the glue dries. Get the wing as flush as you can on top and bottom. When you're happy with the fit, make it permanent. Let's move on to the wing that's in pieces. We're going to start with the inner pieces, wings number 1 and 2. I'll glue those two together. Then I'm going to insert the carbon fiber in the rear hole. I'm going to slide wing 1 and 2 onto the carbon fiber and steel wire. Use a generous amount of glue when you're gluing the wings on. Standing the fuse up on its side again, align it the best you can. Wipe any excess glue off, then hit it with accelerator. Maintain pressure on it as it dries. Now slide wing number 3 on. Go ahead and glue that into place. Get wing 3 as flush as you can. Hit that with accelerator. Let's cut our carbon fiber to length and then push it all the way in. You don't need glue on the carbon fiber. Now I'm going to do the same for the steel wire in the front. I'm going to make it flush on one side and then snip the other side off. Now let's install the wing number 4 pieces. The left wing I installed whole, so I'm going to use wing 4 L bed. The right wing we installed in pieces, so I'm going to use wing number 4 S bed. Let's use this steel wire as a guide to help us align the two wing 4 pieces. I'm going to apply glue to two sides of this part, then seat it into place. Hit that with accelerator. Do the same thing for the other side. Applying glue to two surfaces. Put some pressure on it, hit them both with accelerator. Use the steel wire to clean any CA out of the hinge line. For this build I'm going to use the recommended setup, a 2836 1500 kV 4S motor with a 50 amp ESC. I printed the motor mount using ASA. There's two motor mounts that come with the model. One has recessed nuts and the other one doesn't. I'm going to use the motor mount with the recessed nuts. Slide the motor and ESC into fuse 5. Check the polarity of the motor and verify there's clearance for the prop. The prop should be approximately centered in the slot. The motor should sit approximately flush at that back wall. It's a good idea to put the motor in an X configuration, not a plus sign, so that all the screws are accessible. Pull the motor out enough to be able to apply glue to the cylinder. Apply glue to both sides of the motor mount. Slide the motor forward back into its position. Align the motor as straight as you can. There's not much play here anyway. I'm going to go over the motor mount with extra glue before hitting it with accelerator. If you think you're going to mess this part up, leave the motor mount seated in the airframe, then apply glue to where you can. I'm going to put a battery strap around the ESC and wrap it around twice, exposing as much soft Velcro as I can. Now I'm going to put a strip of Velcro in for the battery and another one for the ESC. I always hit the Velcro at CA on the outside. Stick that guy right there. Let's hinge the Elevons. In this build I'm using 15 gauge music wire. There are links to everything I used on the main download page. Prep 2 pieces of music wire by putting Z-bends in both of them. We're going to use these for the Elevons. Insert the Z-bend on the inside of the control horn. Do this for both Elevons. Last chance to clean any CA out of the pushrod hole. Now insert the music wire with the Elevons attached. Feed it all the way forward. Do this for both sides. We're going to hinge the Elevons using printer filament. I'm going to use ASA on mine. I'm going to start on one side of the Elevons, feeding the filament all the way through from one side to the other. It does help to straighten the filament a little bit before you start feeding it through. This makes hinging the control surfaces very simple, and we can always remove them if there's any issue down the road. We do not need to apply any glue here. If it makes you feel more comfortable, you can melt a flat spot on both ends so that the filament cannot come out. That worked out very nice. Now screw two 9-gram servos into the holders. Make them mirror each other. The Elevons will have about 1/8 of an inch of up elevator built in when we install the servos, also known as reflex. With the servos in their approximate location and the servo wires facing forward, mark each music wire for the location of the Z-bend. Be sure to consult the model files for the recommended hole to use in the servo arm. Then go ahead and make your Z-bend. Slide each servo onto the music wire and put them in their approximate locations. Now we can cut the music wire to length and bend the front so that we don't poke ourselves. With the servo centered, apply a generous amount of glue to the servo holder and insert it into the airframe. Don't forget to add about 1/8 of an inch of up elevator for its neutral position. Now let's do the exact same thing for the other side, keeping both Elevons flush as the glue sets. Hit both of them with the accelerator. Now we can test them and make sure they're both working correctly. I cut the brackets off the servos for the Flaperons and covered them in masking tape. This makes them easier to remove and accept paint better. Route the servo wire through the wing and dry fit it into place. Now do the exact same thing for the other side. Grab some filament so we can hinge the ailerons. I'm going to straighten it a little bit as I mentioned before. Take your steel wire and verify there's no buildup in either hinge line. Feed the printer filament into the hinge line, hinging the flaperon. The filament should hit the fuselage. You do not need to glue this in. Put a Z-bend into a short piece of music wire. Feed the music wire into the aileron from the inside out. Mark the location of the Z-bend. Create the Z-bend and make another wire exactly like this one. Put the music wire back into the aileron from the inside out. Pull the servo out of the wing and put the other end of the music wire into the control arm of the servo. Be sure to check the model files for the recommended hole to use. That worked out great. Now let's do the exact same thing for the other side. Feed the filament through and hinge the flaperon. Insert the music wire from the inside out. Lift your servo up and insert the other end of the music wire into the servo. Apply a very small amount of hot glue to the front and rear of the servo pocket. Glue the servo into the wing in its most neutral position. Same thing for the other side. Glue the front and rear and insert the servo in its most neutral position. Perfect. Bear with me while I do some housekeeping up front. I'm going to tuck all these wires away and install the receiver using Velcro. Now that that's done, let's go ahead and install the optional fin and rudder. Apply glue to the two rudder pieces. Use the table to help you align them. Hit it with accelerator. Now we're going to get a piece of filament and melt one end flat. Holding the fin and rudder, insert the filament through the bottom. Cut it to length and melt the other side. Looking good. Drop the servo in wire first. Seat the servo all the way into the fin. The fin is also one of the parts you may have to hit with your spatula when it comes off the printer. Using the screws that came with the servo, screw the servo into the fin. We're going to need an extension for the rudder servo. Feed the extension through the aft hole in fuse 5. Bend and cut a piece of music wire for the optional rudder servo. We're almost done. Using M2 screws or similar, screw the fin assembly into the stabs. Lastly is the vertical fins. You can use steel wire or carbon fiber in the leading edge of the vertical fins if you wish. Check the length of your steel wire before applying glue. For now I'm going to leave the vertical fins off until after I'm done painting it. Use hot glue to stow the rudder wire on the front of the stab. Put a small bead on the side of the motor compartment and tuck it into the channel there. Now let's see how heavy she is. It's about 730 grams without paint. Included with the model files is a chart with all the printed weights and times on it. Smoking hot. This paint scheme is very easy to do and it really makes the model pop. All I did was take about a 1-inch brush and quickly put some black stripes on it. Let's finish putting her together so we can get her out to the field. Using the steel wires here definitely helped to align the vertical fins. Plus I can pick the airframe up by the vertical fin if I want. Hit the vertical fins with accelerator and put my prop back on. If you guys appreciate all the hard work that I put into this project, let me know by hitting that like button. Let's take these guys out to the field and have some fun. What airframe would you guys like to see me do next? Let me know down below. Alright guys, let's have some fun. I'm ready to go. I can't wait to fly this thing.